IFR training videos, by
Toga Thrust.
ADF approach at Valenciennes, Lfav. After a departure towards Chivers from Charleroi Airport, we are overflying the final waypoint of our SID, CIV, and we are setting course towards Denain, as we have to use the standard arrival plate from Lille LFQQ because Valenciennes doesn't have any star. Once on course for the star, there are big chances that the ATC clears us direct to Victor Serra NDB of Valenciennes. Once the SID is finished, we are in the cruise mode where we have to take care of our cruise alternates. Once we are taking care of our last en route alternate, we also have to compute the top of descent as we are approaching destination. We add 30 miles to the top of descent computed distance, and that's the distance at which we have to prepare our approach, add some miles taking care of any tailwind. We start with the weather, take the ATIS and analyze the runway and type of approach, wind within limits and crosswind component, visibility, RVR and cloud base for minimas, temperature and dew point for rain and icing threat, QNH for altimeter, weather changes foreseen if any. Then, check the fuel remaining, if balanced and sufficient, and make a fast holding fuel remaining computation. Check the NOTAMs in your flight folder for your destination airport. Start the cockpit configuration for the step-by-step follow-up of the approach, what is called IFRBT in new CAG Air Academy. Initialize G1000, flight plan consistency, radios setting, bug setting, transponder code and mode. Once finish the cockpit preparation, which is asking for a complete review of the approach plate, you can brief the non-flying pilot or yourself if you are alone. Review the full approach plate in plan view and profile view with the different steps, check the minimas, check the go-around procedure, the MSA, what to do in case of downgrade, any restriction on the plate, check the airport plate for runway length, exit to taxiway, parking, talk about threats of the day and specials if any. All this is explained in the approach preparation module. Now everything is ready, briefing is complete and cockpit is set up, we receive a clearance for descent when convenient to 2,000 feet on a direct course to Victor Sierra NDB. Altitude is set on the G1000 altitude window and we stand by for descent when reaching the top of descent point. Let's start the descent now.
During the descent, let's put our mind back in place and find our next step by applying the procedures and acronyms. Weather, fuel, NOTAMs, briefing, perfos, threats and special, all has been reviewed and briefed. Turn, we go to Victor Sierra. Time, chrono is reset, time has been recorded on the flight log. Twist, G1000, nav frequencies, COM frequencies, bearing 1, bearing 2, CDI, transponder, bugs have been set. For the moment, we navigate with the GPS to Victor Sierra. Talk, we are in contact with the approach and we reported and acknowledged all the clearances. Throttle, power is reduced for the descent, speed is good and no icing detected. Next step, we'll be entering the parallel entry overhead Victor Sierra with a first heading of 110 degrees and a right turn. Let's take advantage of the few minutes we have to remind how to brief an approach plate. Take the Jepson chart Lfav 16-1 and follow me through. We are preparing an approach in Valenciennes, France, NDB runway 11. Chart 16-1 published on the 24th of February 2023.
Frequency is 317, final approach course 110 degrees, altitude over NDB is 1,500 feet, DEA, MDA is 650 feet. Airport elevation is 165 feet, minimum sector altitude is 2,700 feet at the highest, 2,000 feet in the go-around.
If local ATS not available, obtain Leal altimeter setting from Leal ATIS or Leal approach. Pilot controlled lighting 122.605. Racetrack limited to maximum 170 knots. When reaching Victor Sierra, enter the racetrack via a parallel entry procedure, heading 290 degrees, right turn. After the entry, perform the racetrack at 2,000 feet. When turning inbound to Victor Sierra NDB, descend to 1,500 feet, configure with flaps approach. Overhead Victor Sierra, apply the 5 grams, gear, glide, go timer, go around altitude, green lights. Timer will be for 1 minute and 59 seconds to the missed approach point for a ground speed of 100 knots. Follow the descent path down to the minimas of 650 feet. We need an RVR of 1,500 meters. We will not refer to a GPS point, so the table altitude versus distance is not applicable. At the minimas, in case of go around, climb on 097 degrees heading to 1,100 feet, then turn left at maximum 160 knots to the NDB climbing to 2,000 feet. We have a displace threshold. Now that we are approaching Victor Sierra, we quit the GPS navigation to switch to pure NDB navigation. We will not use the radial 046 degrees of Combray to cross-check the position of the NDB, just working with the NDB to make things a bit more difficult. So we can put bearing 1 and bearing 2 on ADF, set the minimums at 650 feet, set the CDI on the holding radial to help for positioning. DME is not important, VOR frequencies are not important as we do not use them. So, to follow the regular setting path, we do G1000 no change, VOR frequencies, no change, COM frequencies. When instructed, contact Leal approach on 126.480, standby COM frequency on Volocyan info 122.605. DME not used, bearing 1 on ADF, bearing 2 on ADF, CDI tail of the needle on holding radial, ADF. Check the frequency of Victor Sierra and ident the beacon with the Morse code. Transponder check on alt, bugs and minima set. Here, we are setting a ghost frequency on the VOR to be free of the CDI, by adding 0.5 to an existing frequency. By doing that, we can use the CDI as a reminder without being tricked by a CDI that would eventually come centered. Then we set the CDI tail on the holding radial 290 degrees to be able to visualize more easily the racetrack on our PFD. Note that we fly with the magenta diamond, wind bug, on top of the navigation needle, ADF needle, so we will not drift away due to a crosswind. Our heading bug, blue, correspond to a ground track, magenta. Of course, refer to the holding module. As we are approaching the holding facility, we apply the holding preparation procedure. 1. Reduce the speed to holding speed. 2. Check the facility frequency or holding waypoint is the 2 waypoint. 3. Check that the bearing 1 is set on the holding facility, ADF, VOR or GPS, here, ADF. 4. Set the CDI tail of the needle on the holding radial. 5. Compute the entry. Once overhead the station, wait for the needle to revert. Then, apply what you computed earlier, a parallel entry, outbound track 290 degrees, right turn. To establish on AQD are 290 degrees, that is an angle of difference with the initial heading of about 60 degrees. 1/3 of 60 degrees is 20 degrees. So we will continue the turn further by 20 degrees, making it a track 310 degrees. That will allow us to position ourselves on the correct radial and stay outside of the non-protected area. Starting the turn, apply the next step concept. Turn, time and twist, talk, throttle, next step. Turn, to heading 310 degrees. Time, start the timer. Twist, heading bug, the rest is already done. Talk, report entering the racetrack. Throttle, check speed versus power and signs of icing. Next step, turn right back to the station. Remember, we are flying or intercepting radials, which are ground references, so we do not put the heading bug on 310 degrees, but the magenta diamond which represents a ground track. We then follow the corresponding heading. We have intercepted the outbound radial and we are correctly positioned. At 1 minute outbound, we can turn right, back to the beacon. As for each turn, we proceed with the next step concept. Turn towards the beacon, time, off, reset, twist, heading bug, talk, nothing, throttle, check power versus speed and icing clues. Next step will be, overhead the station, turn left on the outbound track. Overhead the station, apply the next step you decided. Turn, left to the outbound track 290 degrees corrected for the crosswind. Time, ready to start when crossing a beam the station. Twist, turn the heading bug. Talk, nothing to say. Throttle, check speed versus power and icing clues. Next step, will be start the timer. Abeam the station, start the timer. Here, we see that we have no crosswind, so, no correction to apply laterally. Otherwise we would have to apply a correction equals to the crosswind component, refer to the holding module. We see also that we have a tailwind of 12 knots, we will then reduce the outbound time by half of this number, that is 6 seconds, for an outbound time of 54 seconds and a 2/3 of time of 36 seconds. So, at 36 seconds, we should have a relative bearing of 220 degrees, or 40 degrees to the tail of the needle, and we should be on the teardrop, relative bearing of 210 degrees, 30 degrees to the tail, at 54 seconds. If not, we apply the correction depicted in the holding module. We were too early at the bearing 220 degrees, 40 degrees to the tail, so, we turn to the needle to follow the teardrop until the end of the outbound time to correct our position. At the end of the decided time, we start the turn left to the inbound, and we apply, of course, the next step concept. Turn to the inbound course 110 degrees corrected for QDM interception. Time for an holding, we would let it run as we have to pass overhead the station at the 3 minutes marker, but here, we are on approach and we have to start the timer for the descent, so reset it now. Twist, heading bug. Talk, report turning inbound. Approach will switch you to information on 122.605. Throttle, reduce for descent. Next step, level off at 1,500 feet in flaps. Once on final, no more turns, use only the next step. Next step will be, at Victor Sierra, 5 Gs. Let the speed drop off and configure with the approach flaps. Adjust your heading to track efficiently the QDM. On small aircrafts, use the rudder to initiate the turn, otherwise the aircraft will skid but won't turn fast enough. Use the magenta diamond intelligently. Do not forget to perform the descent checklist and the approach checklist, if not already done. At Victor Sierra. Gear, down. Glide, start descent at 600 feet per minute according the descent scale. Go timer, start timer for 1 minute and 59 seconds. Go around altitude, set 2000 feet. Green lights, check gear and flaps lights. Next will be 1000 feet AGL, 1200 feet baro. 1,200 feet borrow, check approach band. If you have the prescribed minimas, continue, if not, go around. Next will be 500 feet above the minimas, 1,150 feet. Already there, check stabilized and checklist complete. If not, go around. Report final to the information. Next will be 100 feet above the minimas, 750 feet borrow, start looking outside searching for visual clues. Next will be minimas, continue or go around. Minimas. Go around. Apply the aircraft's go-around procedure and follow the missed approach path described on the plate. You surely noticed that we arrived a bit before the end of the minute and 59 seconds. Surely because our ground speed was a bit too fast, but, as we are flying this approach in CDFA, we are not allowed to fly a step waiting for the timer, so it's an immediate go-around required. Fly on heading 097 degrees until passing 1,100 feet, then turn left to the NDB climbing to 2,000 feet. This approach is one of the most difficult on NDB, it requires a good structure and needs you to be ahead of the aircraft at all times. Know what to do well before having to do it, otherwise you will be overwhelmed by events. Reaching the NDB, you can enter the hold using the racetrack, restart another approach or decide to divert to your alternate. This complete the description of the NDB approach in Valenciennes. Note that during the go-around, you will have to contact Lille approach to receive another IFR clearance.